It raised more money than almost any startup in European history. More than $10 billion from Goldman Sachs, from Volkswagen, from the Swedish state itself. It signed something like $50 billion in orders before it had shipped at scale. It was going to be the factory that freed an entire continent from its dependence on China. 4 years later, it was the biggest bankruptcy Sweden had seen in a generation, sitting on billions of dollars of debt, its value marked all the way down to zero. That company was Northvolt, and the thing that killed it was not China, and it was not weak demand for electric cars. Those are the answers everyone reaches for. The real answer is a single number that most people have never heard of, and it was hiding inside one building near the Arctic Circle. Here is what a battery gigafactory actually costs, where the money is supposed to come from, and the one number that decides whether a factory this size becomes an empire or a grave. The buy-in. Start with the name, because it tells you the scale. Gigafactory is a factory whose output is measured in gigawatt hours, billions of watt hours of battery capacity per year. The word was popularized by Tesla. It now describes the most expensive category of factory being built anywhere on Earth that is not a computer chip plant. Building one is a multi-billion-dollar commitment before a single cell ships. A serious gigafactory runs into the billions of dollars to construct, and Northvolt raised more than $10 billion, some counts putting the total financing near $15 billion, and still ran out of money. And the money buys something stranger than a normal factory. Inside are dry rooms held at humidity levels lower than a desert, because water ruins the chemistry. Coating lines that spread active material onto metal foil at the speed of a printing press. Ovens, enormous presses, and a step called formation, where every single cell is slowly charged and discharged for the first time, sometimes for hours, before it can be sold. You do not just assemble a battery. You have to wake each one up and test it, one at a time by the million. The rule of thumb in the industry is brutal. 18 months to build the factory, then another 15 months to reach full production. Almost 3 years from breaking ground to running at full speed. And every month of that, the money is flowing out and nothing is coming in. What you inherit. You inherit the steepest learning curve in modern manufacturing. Gigafactory is often compared to a semiconductor plant, and for one reason. When you first switch it on, most of what it makes is garbage. The industry word is yield, the percentage of cells you produce that are actually good enough to sell. Early on, that number can be shockingly low. A huge share of your first output goes straight into the scrap bin, and you has paid full price in materials, energy, and labor for every ruined cell. Getting yield up from terrible to acceptable to world-class is the entire game. The Asian giants, China's CATL, Korea's LG, have spent decades and countless factories climbing that curve. A new entrant has to climb it from the bottom, while burning millions of dollars a week. Nobody hands you that knowledge. You buy it one ruined cell at a time. You also inherit a chemistry set the size of a town. The cathode material, the anode, the electrolyte, the separator, much of it refined in China, which controls the overwhelming majority of the world's cell production and processing. So, even as you build a factory to escape that dependence, you often start out buying your key materials from the very country you are trying to compete with. The revenue layers. Number 1. Cells sold by the gigawatt hour, mostly to car makers. The buyer is usually an automaker who has signed a long-term contract years in advance, the way Northvolt signed with Volkswagen, BMW, and Scania. On paper, that order book is your fortune. Northvolt was sitting on something like $50 billion in orders. Orders, though, are a promise to buy cells that actually work, delivered on time. They are not money in the bank. Number 2. Scale itself. A plant making 50 gigawatt hours a year reaches a cost per cell that a small plant cannot touch. In batteries, bigger is not just better. It is survival. This is why nobody builds a small one. Number 3. the recycling loop at the end of the cell's life, recovering lithium, nickel, and cobalt from dead batteries. Northvolt built exactly this beside its main plant. It is real, and it is the future. It is also years away from paying for the factory in front of it. Now stop, because there is one number that governs every one of these layers, and it is the number that killed Northvolt. Listen to that again. Northvolt's flagship plant in Skellefteå, in the far north of Sweden, was designed to produce 16 gigawatt-hours of battery cells a year. It reached 1. Read that again. A factory built and equipped for 16, that raised over $10 billion on the promise of 16, was in practice delivering about 1 gigawatt-hour. That is not a small miss. That is the machine failing to do the one thing it was built to do. That gap between the capacity you paid for and the good cells you can actually produce has a name. It is the yield ramp, and it is where battery empires go to die. Every wasted cell is full cost and zero revenue. Run a giant plant at a fraction of its yield, and you are paying for 16 while selling one with billions in debt underneath you. The consequence came fast. In the middle of 2024, BMW walked away from a battery order reported to be worth around $2 billion and handed it to a competitor because Northvolt could not deliver. Listen to that again. A single customer, a single canceled order, $2 billion gone because the yield would not climb. The ledger. The single largest cost in a battery is not the factory. It is the materials inside the cell: lithium, nickel, cobalt, graphite, and the processing to turn them into battery-grade powder. When you scrap a bad cell, you are throwing away all of that, already paid for. Then, energy in enormous quantity, which is exactly why Northvolt chose northern Sweden, for its cheap, clean hydropower. Then the people, thousands of them, many recruited from abroad and trained from scratch, because a region near the Arctic Circle did not have a battery workforce waiting. And underneath all of it, the debt. A gigafactory is built on borrowed billions, and the interest does not wait for your yield to improve. That is the vice. Costs, materials, energy, payroll, interest, all running at full scale from day one, while revenue waits on a yield number that is climbing far too slowly. The trap. Here is the trap, and it is unlike any other factory in this series. A gigafactory has to be enormous to be competitive, which means it must be built at full scale before it has proven it can run at full scale. You commit billions, hire thousands, and switch on a plant the size of dozens of football fields, all on the belief that you will climb the yield curve fast enough to justify it. There is no small version to test first. Scale is the only way to be cheap enough to survive, so you must bet everything before you know if it works. Northvolt made that bet. It built for 16, staffed for 16, borrowed for 16, and the yield stalled near 1. Once that gap opened, no amount of new funding could close fast enough, because every extra month of low yield burned more cash than any investor would keep pouring in. And there is no shortcut. A car maker can build one car, test it, and fix the next. A gigafactory owner cannot build 1/10 of a factory. The trap in one sentence: you must build the whole cathedral before you find out if the roof will hold. The history digression. The man who made all of this possible made almost nothing from it. In 1980, at Oxford University, a physicist named John Goodenough discovered the cathode that made the modern lithium-ion battery possible, a layered cobalt oxide that roughly doubled a battery's voltage, and let the technology leave the laboratory. Every cell Northvolt tried to build, every phone in your pocket, traces back to that breakthrough. Oxford declined to patent it. Goodenough signed the rights over to a British atomic energy body and never earned a fortune from the invention that would soon power a trillion-dollar industry. Sony commercialized the first lithium-ion battery in 1991 using his chemistry. He kept working decade after decade. In 2019, at the age of 97, John Goodenough became the oldest person ever to win a Nobel Prize. He was still going into the lab. He worked until he was 100 years old. The chemistry was never the hard part. Goodenough handed the world a working battery more than 40 years ago. The hard part, the part that swallowed $10 billion in Sweden, was making it at scale without ruining most of what you make. The death spiral case. So walk the fall of Northvolt in order, because it is the whole business in one company. Founded in 2016 by two former Tesla executives, backed by more than $10 billion from Volkswagen, which took a 21% stake, from Goldman Sachs, which took 19%, and from public money, $50 billion in orders on the books. A gleaming plant in Skellefteå, Europe's great hope. Then the yield would not climb. 16 gigawatt hours of capacity produced about 1. BMW canceled its roughly $2 billion order in mid-2024. A $5 billion loan to expand was pulled as the problems mounted. Money ran out. In November 2024, the company filed for bankruptcy protection in the United States. It raised a little emergency financing, including from the truck maker Scania, and still could not climb the curve fast enough. On the 12th of March 2025, Northvolt filed for bankruptcy in Sweden, one of the largest in the nation's history, with billions of dollars of debt. Goldman Sachs wrote its stake, hundreds of millions of dollars, to zero. So did Volkswagen. A $12 billion company became worth nothing, not because the world stopped wanting batteries, but because it could not make enough good ones fast enough to service its debt. The survivors. Habit 1. Climb the curve somewhere cheap before you bet the continent. The Asian giants did not start at 16 gigawatt hours. They spent years and many plants learning to lift yield before scaling to enormous size. Habit 2. Buy the process, not just the building. The winners obsess over the boring middle of the factory, the coating, the drying, the formation, because that is where yield is won or lost, not in the press release. Habit 3. Do not let the order book fool you. 50 billion in orders meant nothing once the cells would not pass. Contracts convert to cash only when good product ships on time. Habit 4. Keep enough capital to survive a slow ramp, because the ramp is always slower than the plan, and the debt never is. The verdict. Does this actually work? It can. CATL and BYD in China, LG in Korea, run gigafactories that print money because they climbed the yield curve years ago and now sit at the top of it, making good cells by the billion at a cost nobody else can match. That is the good year. A plant humming near full yield, cranking out cells at world-beating cost, feeding a planet that needs more batteries every single year. The bad year does not look like slow sales. It looks like a brand new, multi-billion-dollar plant, fully staffed, fully financed, running at a fraction of its yield, scrapping most of what it makes, while the interest clock runs. That is not a downturn. That is Northvolt, and it ended at zero. You never really bought a battery factory. You bought a bet that you could climb the hardest curve in manufacturing faster than your money ran out. Win that race and you own the future. Lose it, and you own the most expensive scrap heap ever built.